So good afternoon, everybody, and sorry for the problems with the technology. I'm glad to present about the IPCC special report on climate change and land. Next slide. This report has a long title, but it is essentially about all the land challenges and how they interact with climate change. Next slide. In this report, we had scoping which was performed through some interactions with the Bureau of IPCC and with some of the governments involved. And this led to the following structures in terms of the chapters. We have framing and context, and we address the interactions between land and climate. Then three challenges that are interacting, desertification, land degradation, and food security. And then in chapter 6, how are they interlinked, and which are the responses, and how these responses may provide co-benefits, synergies, and trade-offs. And then we addressed the decision-making through more the socioeconomic dimensions in relation to sustainable development in chapter 7, which is the last chapter of this report. Next slide. So obviously, land provides the basis for human livelihoods and well-being. What we can show in the report is that warming over land has occurred at a faster rate than the global mean. The global mean is currently 0.85 degrees Celsius of warming, and on land areas, the mean is 1.5 degrees Celsius, so approximately the double. And this is over the recent years compared to the pre-industrial times. We also know of the unprecedented loss of biodiversity on land, and we know that climate change is adding to these challenges. So we need to buffer the negative impacts from the overexploitation of the resources, and we also need to restrict warming in order to reduce the negative impacts of climate change on land. Next slide. This report has updated the views on emissions from land. The agriculture, forestry, and land use sector, which is called AFOLU, contributes to about 23% of the total global anthropogenic greenhouse gas emissions. And this fraction or percentage is higher for the methane, 44%. And we know also that there are large nitrous oxide emissions, since about 50% of the nitrogen applied to the crops, to the agricultural land or to the pastures, is not uptaken and results in such nitrous oxide emissions. Moreover, the grazing lands contribute strongly to the nitrous oxide emissions, and approximately to 1/2 of the total emissions from agriculture. Next slide. We do observe some impacts of climate change on food security. Yields of some crops, like maize and wheat, have already declined compared to yields in the absence of climate change in some especially low latitude regions, while in many high latitude regions the yields of some other crops like sugar beet have increased due to warming over the recent decades. We also can observe the reduction in animal growth rates and productivity in some of the pastoral systems. Here again, this is in Africa and other tropical regions. And we can also see that the pests and diseases are changing in response to climate change, which may result in increase or in some cases decreases of the infestations. Next slide. We do have a strong warning message here about the risks to food supply stability as a result of climate change. In fact, we can show that the stability of food supply is at risk it is projected to decrease as the magnitude and frequency of the extreme events increase. And this may happen, as you can see from this colored bar graph, which we call a burning amber graph, where you see a scale which is in terms of global warming compared to pre-industrial. So when we start on this graph to look at 1 degree Celsius warming compared to pre-industrial, we find that there are risks from infrequent price spikes that are partly caused by warming that affect individual countries. And the risks become high when we are already around 2 degrees Celsius. There we have periodic food shocks across regions. And if we go beyond 2 degrees Celsius, we enter into a very dangerous area with high probability of severe impacts and the presence of some irreversibility caused by climate hazards. And this is especially in terms of the sustained food supply disruptions globally. So I must say that this conclusion, which is based on the recent literature, is in fact more pessimistic than the one we had some years ago in the 5th assessment report, where we said that food security would be severely at risk after warming scenario of 4 degrees Celsius. So the recent literature updates this and shows that there are risks for food supply disruptions, even at global scale, starting from slightly above 2 degrees Celsius. There are also some concerns about the decrease in the nutritional quality of crops with the increase in the atmospheric CO2 level. And we show also the range of variation in food prices due to climate change by 2050. And I must say the range is quite large. It is between 2 and 23%, but the median is an increase by 7% in food prices. So this can also lead to increased food insecurity. The most vulnerable people, which are especially smallholders and farmers, pastoral people living in tropical areas, will be more severely affected. And we can also show from the literature that increased warming may amplify the migration risks, both within countries and across borders. Next slide. However, there is significant mitigation potential from the response option we could deploy in the global food systems. Emissions in that system are estimated to range between 21 and 37% of total net anthropogenic greenhouse gas emissions. This is higher than emissions from the agricultural, forestry, and land use sector, because here are included emissions from the transportation of food, from also the agri-food industries, and the retailing. So we could deploy response option across the entire food system, from production to consumption, including reductions in food losses and wastes, and this could be scaled up to support adaptation and mitigation. We have also findings that show that deploying options like soil carbon sequestration and agroforestry may deliver co-benefits across various land-based challenges. I will go back to this. And we find a large technical mitigation potential in agriculture from crop, livestock, and agroforestry, however quite uncertain, with a range between 2.3 and 9.6 gigaton of CO2 equivalent per year by 2050. Next slide. So let's maybe go back to the challenges. And here you have maps that are in chapter 6 of this report that take a sort of systematic approach to look at where are the high risks from the challenges. So on the top left, you have the anthropes, or land use types, if you prefer. Anthrope is a term that was developed in ecology to explain that these are biomes used by humans. Then on the top right, you have climate change adaptation, and in purple, you have high risks from changes in seasonal cycles by the end of century compared to current. On the bottom left, you have the risk from desertification associated to land use change or land management, You have other areas which experience desertification from climate change, but they are not shown here in yellow. Here it's only from land use. And on the bottom right, you have the land degradation map using a soil erosion proxy. You can see that, in fact, several challenges may overlap. So if you look, let's say, at South Asia, like India, you see high risk from seasonal dissimilarity, from soil erosion also. Next slide. Sorry, I didn't see it. Yes, here you have the other challenges like food insecurity. So here again in India, you have also food insecurity on top of land degradation, risk from climate change adaptation. And you have also on the top right, the threatened hotspots of biodiversity. And so you can find regions where here again this challenge to biodiversity overlaps with other challenges. And on the bottom, you have the groundwater stress and the water quality stresses with excess nitrogen and phosphorus loads. So the general message, I think it will appear in the next slide. Can I get, yeah, thank you. Oh, maybe we missed one. Okay, yeah, thank you, here it is. Yeah, because we have those different challenges, we want to understand which are the responses that could create benefits for those challenges. And we studied in much detail in chapter 6 about 40 responses that we divide into sustainable land management, into value chain management, and into risk management options. And we systematically tried to assess the impacts of those response options on the mitigation, adaptation, desertification, land degradation, and food security challenges. And we also estimated the cost of those responses. So without entering into details, on a global scale, when you are with a blue color, especially with a dark blue, you have a large positive effect. If you are with a dark red effect, you are with a large negative effect for each of those challenges. Next slide. So you have here this table with the challenges in columns and the responses that are here, the land management responses in lines. And let me maybe just take two contrasted examples. One will be increased soil organic carbon content. That is in the soil category, in the lines. So that line is fully blue, which means that increasing soil organic carbon delivers co-benefits across the challenges. In comparison, if we look at large-scale deployment of bioenergy with carbon capture and storage, this is the last line, there are some trade-offs. So there are some positive effects for mitigation, but there are trade-offs with adaptation, food security, and biodiversity. Next slide. So we come to the following conclusions that across countries, the greater the number of land challenges, the fewer the responses with only co-benefits, and the lower the human development index. If we are fortunate to live in temperate regions, we are usually in regions where the number of land-based challenges is relatively low. So on the top map at the left, you will see some colors in brown that show moderate levels of challenges, like 1 to 2 or 3 challenges. And that's typically what we have in the temperate regions. These are regions where also the human development index is high. And if you look at here again, India as an example, you see the number of challenges in India is high, it is in the greens, and the human development index is on average lower than in the temperate regions. And quite much of the same applies to Africa, for instance. And also we find that on the bottom graph, that the number of responses that deliver co-benefits across challenges is actually lower in India and also lower in some parts of the tropical regions than it is usually in the temperate regions. So you see that we have reasons of concern. These are that in countries which already are struggling for their development, we have more challenges and less responses that can deliver across all the challenges that are encountered locally. Next slide. So we've been looking into this chapter in more detail. What is the area where we could potentially deploy responses with only co-benefits or with some trade-offs? So without going into the details, you have on the right part of the graphs where you can deploy responses with only co-benefits for croplands, rangelands, villages, and so on, where there would be no harm. So that's in white actually. There would be actually no large trade-off, negative trade-off across challenges. And in contrast, on the left of the graph, you have horizontal bars in black, in dark, which show negative trade-offs. And here again, if you look at bioenergy and BECCS, there might be negative trade-offs across challenges if you deploy this at scale. Next slide. So we can see this with the deployment area with only co-benefits with increased soil organic carbon content. You could deploy it essentially on most of the I3 land area where the soil is not barren, where you are not in a desert. So this could be creating co-benefits in many situations. And if you look at potential trade-offs with bioenergy and BECCS, there are many areas where there are potential trade-offs because you have challenges for food security or for desertification and so on, which are not helped for by the bioenergy and BECCS. Next slide. So in terms of options, fighting against desertification and land degradation delivers co-benefits for the climate, for adaptation and mitigation. And you have examples here how you could do this with terraced crops or regreening some of the deserted areas. This could also have some positive impacts on biodiversity and sustainable development, and could help increasing carbon storage in soils and promoting agricultural productivity and food security. Next slide. But if we look at the large-scale deployment option of mitigation options such as bioenergy and afforestation, from the integrated assessment models, you may enter into negative impacts for food security, biodiversity, and land degradation. If you are with a high population, this may happen even for deployment with less than 1 million kilometers square. And if you are in a low population scenario, it would be between 1 and 4 million kilometers square, the areas that would start impacting negatively food security and biodiversity, land degradation with this large-scale deployment of those options. Next slide. So we can nevertheless say that if we have a deployment on a small scale with best practices, there are co-benefits from bioenergy and BECCS, reforestation, afforestation, and biochar. So we have to nuance a bit this assessment. There are many options to deploy bioenergy, but if you start deploying it on millions of kilometers square, there are also significant trade-offs and risks. Next slide. So now we address value chain and risk management response options with the same color grid as before. And I'd like to highlight some options like reducing food waste, which is the third from the top. And this delivers co-benefits for most challenges. We do not have enough data to assess it for adaptation, but for the other challenges, it is leading to co-benefits. The same holds for dietary changes that would actually converge towards the nutritional recommendations from the World Health Organization. And this implies in some of the OECD countries reducing meat consumption, but it would not be the same in some of the poor countries where actually the meat consumption is already very low. meat and other animal products can provide a strong contribution to food security in those countries. In terms of the risk management options, we have also some understanding that we need to manage urban sprawl, so limit the conversion of agricultural soils to artificial soils, artificialized areas where there are cities. And we did not find maybe enough data on risk-sharing instruments, on insurances and such mechanisms. So there is still uncertainty on such issues. Next slide. Coming back to food, we could assess that food losses and waste contribute to 8–10% of the greenhouse gas emissions. We know that between 25 and 30% of food production is lost or wasted. So the losses happen mostly in the developing countries and the wastes in the developed countries, food waste. And reducing those losses and waste could release millions of kilometers square of land by 2050 for instance, a better maintenance of the soils, for mitigation or for biodiversity. We do realize that diversification of the diets with more fruits, vegetables, protein crops and nuts, this is aligned with some of the healthy diets recommendations, could benefit to the diversification of production systems. We would then have integrated systems, some better use of genetic diversity. We could also have some less maybe livestock but low emission livestock, and this would support climate change adaptation and mitigation. And here again, those food transitions could release millions of kilometers square of land with co-benefits for the environment and health. And this could lead to an emission reduction that is quite uncertain, but in some of the papers we could review leads to quite high values. Next slide. I will be now looking into the different socioeconomic pathways and how they affect the levels of climate-related risks. So you see, SSP1 is a world where the population increase is moderate. We would reach approximately 8.5 billion by 2050, whereas SSP3 is a world where we reach 10 billion by 2050 of global population. And in SSP3, we also have some relatively low income, so there are quite a lot of poverty, some strong inequalities, and we do not have strong environmental policies. This is just the opposite in SSP1, which is an environmentally friendly world, which has relatively high income. So if you compare the risks from climate change in those two contrasted scenarios, you see that the risks for food security are much higher under SSP3 than under SSP1, and the same applies for land degradation and desertification. So global warming, climate change, is creating risks, but those risks are much stronger in some of the socioeconomic pathways. So it is equally important to ensure sustainable development and to fight against climate change. Next slide. And this is what we get out of the integrated assessment models in terms of the changes in land use, which also have significant impacts, say, on bioenergy. So most of the foreseen changes have a large development in bioenergy crops in purple. You can see that the purple line goes up in each case. You can also see that forests are expected to go up in terms of land use in the future in all pathways. And in contrast, the pastures and the croplands tend to go down. I must say that this is, in my view, based on rather optimistic scenarios of progressions in yields, in crop yields, and rather optimistic scenarios also in terms of changes in diets and food waste. So I think that we are in a narrow pathway of viability because we need to create strong mitigation on land because mitigation in the other sectors is maybe not enough to reach 1.5 degrees Celsius, to have carbon neutrality by 2050. So this is why you need to have bioenergy crops and forests. But on the other hand, we need to cope with the increased food demand from a rising population. And to get this on only a small area of land means that you need to have a strong increase in agricultural productivity without creating further negative impacts on other dimensions like soils, biodiversity, and so on. It is really a strong challenge. Next slide. So obviously we have in this report a sense of urgency, and we can say that delaying climate change mitigation and adaptation will create increasingly negative impacts on land. We need to have some actions, otherwise we will have not much potential of the sustainable land management options. We can have also irreversible impacts on ecosystems. And if we do have a rapid action on climate change aligned with sustainable management, sustainable development, we can reduce the risk to millions of people from climate extremes, desertification, land degradation, and climate change, food insecurity. So quite clearly, we cannot postpone greenhouse gas emission reductions without creating greater economic impact for many countries. Next slide. Okay, so this was my brief presentation of this report, and you have here the summary for policymaker. You can download the report, and certainly you can have a more in-depth look into this report. I'd just like to conclude by saying a few words about that's the next slide. Starting by the global dimension with the pledges for the Paris Agreement on climate. Just to remind you that this agreement is not enough in order to reach 1.6 by the century, and that we can say that in fact we need to have more emission reductions. There is a gap of emission reduction by 13 billion of CO2 to reach targeted global warming, and it's even a much bigger gap, 29 gigatons of CO2 equivalent, if we want to reach a 1.5 degrees Celsius target. So this is why, because the agreement on emission reduction is not really enough, that we need to have negative emissions. And if we think about the mitigation goals so far in Europe for agriculture in the non-ETS sector, there are some rather strong commitments. So for a country like France, you see that compared to 2005, by 2030, we need to abate our emissions by 37%. And this is in itself a strong challenge, reducing nitrous oxide and methane emissions from agriculture by 37%. It's even slightly more in other countries like Germany or Denmark and so on. However, this is also the target we have in our national strategies that commits to carbon neutrality in 2050. And we are, with that strategy, asked to have a 1.5% annual reduction in agricultural greenhouse gas emissions, starting very soon in 2021 until 2025. And after this, this will be even a stronger demand on mitigation in agriculture. Next slide. So I think it's nice you have this bioeconomy conference, because the way we can achieve all this is, as you understand, very much integrated. How can we create that mitigation and that climate change adaptation in a circular bioeconomy? And this slide, which is taken actually from the Animal Task Force, shows that you can conceive systems where you have a lot of recycling. They may also involve livestock. They may also be connected with energy production. But I would like just, because we have no time to discuss all the issues here, I would just like to focus on the next slide on one option, which is how could we actually create in Europe soil organic carbon sequestration. You have seen from the IPCC report, this is an option with many co-benefits. And I'd like also to say that in the context of Europe, we have some arable soils where the soil organic carbon stocks have been depleted by agricultural practices. But in those soils, we also tend to have some surplus of nitrogen. So if we immobilize carbon in the soil, we could also, if we store carbon in the soil, soil organic carbon, we could also immobilize nitrogen in the soil, and this would actually help in terms of the nitrogen cycling. So this is one of the, let's say, elements we can bring also for Europe in terms of rebalancing the carbon and nitrogen cycles. Next slide. And that's where we have a coordinated and support action funded by the European Commission with many countries and in connection with various initiatives. And our view is actually to coordinate research on soil carbon sequestration to deliver the co-benefits we've been showing before. Next slide. And this is a vision we are developing in this project. We would like to have especially a monitoring system of the changes in agricultural soil carbon and associated greenhouse gas emissions. So there we are looking really into large-scale systems that would involve a lot of remote sensing combined with data and models. We would also like to have frontier science. There are some frontiers issued in terms of the functioning of soils with their biodiversity. We would like also to create a better research alignment across countries and to investigate how could we really transition the way, create a transition in the ways soils are used in agriculture. So working along socio-ecological systems change. And this needs obviously capacity building and online collaborative knowledge. So this is just one example of the many initiatives that are developing to address those large-scale challenges. So thank you for your attention. And if we have time, I can answer just a few questions.
Thank you so much, Jean-François, for this very, very interesting presentation. Again, I'm sure there are going to be a few questions in the audience. Any questions for Jean-François? You're not making Tivicia.
Good afternoon, Tevesia Ronzon from the JRC. You mentioned that the moment that, can you hear me? That in last IPCC report you are more pessimistic, in particular in food security and food supply questions than for the fifth report. And I would like to know why your projections are now more pessimistic than before. Is it because you have new data or new insights, or because it is worsening?
So sorry, but the sound is not too good. Maybe Laurie, could you try to?
I can try.
I could not hear the question. I'm sorry.
Okay, if I reframe it properly, or I can just give that mic to Tivicia, maybe that's better. Just keep it close to your mouth.
To make it short, can you hear me? My question was why the new projections in the new report are more pessimistic for food security, for example, than for the fifth IPCC report you mentioned.
So I'm sorry, here again, the sound is not good. So what I could catch is that you are questioning the projections with food security, is it?
I'm not questioning.
But I could not catch more.
She's wondering why it's more pessimistic now than in assessment report 5.
Okay, thank you. Yes, thank you. I think it is essentially because we got some more recent papers that we could not assess when we were in the fifth assessment report. They were not yet published. And these papers, I think, are especially showing the role of climatic variability. and the role of, let's say, extreme events on regional food security. So this is the imbalance between food supply and food demand. So this was an area of the literature which has been developed quite recently.
Yes, any other questions?
Thanks for your presentation, for this wonderful report. So you made this point, and it's very clear also in the report, that all the BECS technology is really a problem. And when reading the SSP 1.5, like all the scenario where to reduce the CO2 emission, we're relying a lot on BECS. And the only one which was added, the low emission demand, was making the claim that the only possibility to decrease CO2 in 2050 to reach the targets were by total decoupling of economic growth and use of fossil fuels, which is something that never existed so far, and there is very low probability to exist. So our reading is that it's not possible without a degrowth of the economy, like or doing another kind of system, which in your report is kind of change of socioeconomic system and so on, but do you agree that plain words, that means we have to radically change the system?
So, sorry, here again, I could catch partly what you said. Maybe if you could recap, sorry, I'm sorry, yeah.
I can try. You tell me, Jean-Michel, if I will summarize it very simply, perhaps.
Please do.
In asking whether you would agree or not that degrowth is the only way, basically.
Yes, because either if decoupling does not exist, or as long as it does not exist, and if we cannot use BECS, the only solution to decrease fossil fuels is to decrease the economy the way we measure it now with GDP.
Yeah. Okay. I'm not here again. I'm not sure I could fully understand you, and I'm sorry for this. But what I understand is that you are questioning if we have decoupling or not, and in terms of the economy and the emissions, and if we cannot use large-scale technologies like that will lead to negative emissions. What are the options unless we reduce the growth? So I'm not able to answer this question because it is far beyond what we can say from literature assessment. I can only say that in the literature you will find with the socioeconomic pathways, contrasted pathways that are exploring those different futures. Some pathways, they trust that we can have a relatively low population with high technology, high income, and still low emissions. Other pathways, they would say that we are going to still use resources intensively, so have high emissions, and this would not be with high growth. So I think basically what the pathways are trying to do is explore the different options. But what I can say is that when you enter into high population, like 10 billion and beyond, you have really problems solving the equation between food demand and bioenergy production or afforestation or carbon storage, because you have intense competition for land. And so you need to have a reduction in food waste and losses. You need to have strong dietary changes. Otherwise, you have such a competition between food demand and bioenergy that if you achieve mitigation, you have a high risk for food security. So I think that we are really on a rather narrow viability pathway. The viable space by 2050 is rather narrow, and this is really a warning that I think the community can convey.
I may add one question, if there isn't from the audience. You say that we need mitigation on land if we should have some sinks of carbon, and at the same time we have to cope, and I'm trying to find a good spot, with a strong food demand increase. So we need sustainable intensification of agriculture. Do you have suggestion or what would be good idea for sustainable intensification of agriculture?
Yes, this was much debated also, but if we stick to the report, we can see there are different possibilities. And this is going back to the land sparing, land sharing debate. If you think about the amount of land that can be used for agriculture, we see that in all projections it is usually declining. This is a very big challenge because it means we need to intensify production, but on the other hand, we should do so with less inputs because we have concerns, say, for nitrous oxide emissions with fertilizers and so on. So you see that here again, what we call agroecology in France is seen as an option, as a solution. Soil carbon sequestration can help. But here again, it is a very challenging pathway that we are asked to develop. It would be an easier pathway if we did not have to account for mitigation on land, because there we could use more land. But if we want to have a contribution of the land sector to the global mitigation, we enter in a very difficult competition for land. I think that's one of the strong messages of this report. And conversely, it says that you need rapid mitigation in the other sectors. Other sectors should not rely too much on what we can do with the land. There are many limitations to what we can do.
Last question for Jean-François? If not, thank you so much for taking the time to be with us again.
Thank you all.
Thanks. Yeah.
All right.